Hi, this video will explain what a Zener diode is, how they differ from standard diodes, and we will look into some common applications for them. In this circuit, I've got a 2V DC or direct current supply in series with a forward biased Zener diode. Forward bias just means the arrow points in the direction of the current flow rather than against it. As you can see, the diode is allowing current to pass through without any problems. In this regard, a Zener diode is much the same as a regular diode. Please see the description for my video on standard diodes if you're not familiar. If I now turn the Zener diode around, then the current will stop flowing. Again, this response is much the same as a standard diode. However, if I look at the specification for this Zener diode, I can see that its breakdown voltage is 10 volts. On a standard diode, exceeding the breakdown voltage would cause the diode to fail, to burn up. Let's see what happens when I increase the voltage past the 10 volt Zener breakdown threshold. As you can see, the Zener diode begins to allow current to flow. Now, you might be wondering, why is this useful? So let's go over a few common uses for Zener diodes. In this simulation, let's say we want to supply 20 volts to our circuit. This load is emulating our circuit. However, unfortunately, we only have a 30 volt power supply available. Well, one easy way around this problem is to add a Zener diode that's reverse biased in series with our circuit. As the Zener diode will drop 10 volts, and then we'll have 20 to spare across our circuit. The outcome is that our load now only has to drop 20 volts. Whilst this method works, it is considered to be not very sophisticated, as if the supply changes, then so will the voltage across the resistor. If instead we use a Zener diode with a Zener breakdown of 20 volts and connect our load in parallel, like so, we have effectively created a Zener diode voltage regulator, which maintains our load at 20 volts. This resistor's purpose is simply to limit the current flowing through a diode to avoid any unwanted heating. This sort of device is extremely useful throughout other electronics, including in AC applications. Thanks for watching, be sure to like the video if you liked it, and have a good day. See ya!